Good morning, everyone. I would like to thank the organizers for inviting me here to be in this amazing, prestigious event. So I'm going to start with the question. Let's see here. Can you imagine what the world is going to look like in about 50 years from now? That question, if you'd have asked us about 200 or 300 years ago, it would have been pretty simple to predict what's going to be like. With the state of technology and how fast we're moving forward and the exponential growth of exponential technology, this is going to be very complicated, if not impossible, to see what the world is going to look like in the near future. Let's look quickly about where we're at right now. Do you know that 90% of the scientists that ever lived in this world live today? Look, for example, at the last 20 years, the advancements we've done here in technology. Look at the patents, for example. We've had exponential growth in the last patents in the last 20 years. Look how many PhDs are we getting in the last 20 years as well. So you can tell there is more people, more scientists, more technologists being infused into the workplace and producing amazing exponential technologies. So just to start with that here, just to transition, let's look, for example, about the computational capabilities and computational powers. In the last, in the 50s, when the integrated circuits came in, we had about 2 transistors per integrated circuit. Today, we have about 20 billion transistors in this integrated circuit. That tells you about huge technology advancements. And then the data that we're having today is about 2.5 quintillion data points per day. That amount of data is impossible to process with the conventional computer power that we have today. You know, data without processing, without meaning something meaningful out of it is completely worthless. So we need to analyze it. We need to make something completely meaningful and useful to be able to be used in what we need to do it. So quantum computers is starting to actually have a huge leeway in being able to process these kind of things. The latest technologies, for example, in quantum computers are able to analyze things 100 million times faster than conventional computers. So if you look, for example, at the progression in the next, for example, 15 years, we expect about the computational power of the systems will be equivalent to human brain. And if we keep going forward with that trend, in about 30 years or 35 years, the computational power will be equivalent to billions of people. So you can imagine the possibilities of that happening. Just look, for example, at the simple technologies we have today. So one of the smartphones, right now, they're starting to implement artificial intelligence chips. Before, we used to send actually the data on the cloud, analyze it, and bring back the data to the phone. But now, actually, for speed, for privacy, for certain things, they're starting to put the artificial intelligence chips in the microprocessors in the phone itself. So this phone, for example, which is kind of basic phone from a couple of years ago, they were able to teach it how to drive this car completely autonomously in about 2 weeks. Can you imagine the possibilities when this smartphone becomes, you know, substantially more powerful in the next 20 or 30 years? What are the implications, the possibilities we'll be able to have? The robotic market as well is enhancing and improving substantially. We expect it's going to be $70 billion in the next 7 or 8 years. And also in terms of jobs, in the United States, we anticipate by the year 2050 is going to impact about 50 million jobs, manual labor jobs, essentially. And these computational robotic systems are becoming much more advanced. This is, for example, Robonaut 2 from NASA. It's one of the most dexterous robots in the world. We're doing partnerships with other people to be able to use in several operations. But then also look at the Boston Dynamics. Look at how amazing this thing is. And by the way, this is today. So extrapolate that kind of things and move forward, like we said, 50 years. I think it's going to be very difficult, very challenging for you to be able to tell a real robot from a human. But you know, the impact of automation on jobs, that's not a new topic. It's been existing for a long time. Look at the Industrial Revolution, for example, at the beginning of the century. People were very afraid, you know, that the robotics, the machines will be able to was going to take a lot of the jobs. But it turned out not to be the case. People readapted and found jobs elsewhere. The only paradigm shift that we're having today is artificial intelligence. So what we're doing is we're no longer competing on manual labor. We are competing on intellect as well. So imagine when we have computational power in the next 30 or 40 years, that's actually equivalent to billions of people. We have a robot so advanced that looks like a human. Essentially, we're creating, in a sense, a new species that's going to be competing with everything that we do here. So right now, for example, we've noticed in basic artificial intelligence algorithms, when you compare them, for example, to radiologists, they were able to do 6% better predictions than conventional doctors. If you look, for example, at Wall Street, they were able to pick and predict portfolios with certain percentage more than seasoned investors that actually had decades of experience in Wall Street Journal and Wall Street market. So all these kind of things actually are today, but imagine when we start going further into these kind of things. So today, I think I classify it into the weak artificial intelligence. We're going to be heading into the general artificial intelligence, which is basically equivalent to the human brain. And then the question, the interest, is going to be when we reach the super artificial intelligence, that's when things will get interesting and things will be completely going in different directions. So artificial intelligence is not something new, right? It's been since the 50s we've been discussing it. So why now? Why is it becoming so popular? So I think it's due to three pillars, basically. The first one is the algorithms. The basic algorithms we had before, they were very principled, single layer. They weren't able to do that good of a job of complexities. The human brain is very, very complex. And the basic algorithms we had until today, they were very simple and lacking in predicting some of these computational necessities that we had. But with the advancements of these new algorithms, there's a substantial amount of researchers working on that, so they were able to make them much more complex and in line with what we're trying to expect. The second thing is also the availability of microprocessors. So right now, for example, until recently, the microprocessor used to do an analysis, do a calculations, and then finish it, and then go to the other one. So in series. So it takes a long time to do these kind of things. Actually, the gaming industry is what changed the equation here. The gaming industry produced GPUs that actually contain thousands of core into each of the microprocessors. So you can actually do thousands of operations at the same time instead of waiting to finish one and go to the other one. And the last one, obviously, is the big data. So all these things as little kids, without actually teaching them and giving them the data, is worthless completely. So now we have vast amount of data that we're feeding to these algorithms, and collectively between all these kind of three things, I think that's where we're starting to have substantially more benefits into artificial intelligence. And the good thing about them is going to be collective learning. For example, humans, when we learn something, it's us individually learning things. But when we have, for example, thousands or hundreds of thousands of millions, for example, of these artificial intelligence robots or humanoid systems, whatever one learns, all of them will learn. So the learning itself actually going to go in an exponential rate as well in terms of how fast everything will be analyzed. But also humans becoming much more effective. We're starting to embed technology. We're having a lot of wearable technologies. And the next phase actually is going to be embedded, implantable technologies in our bodies. So we're becoming actually much more effective as a human species in doing things faster and more effective. So in a sense, it's going to be a little bit different. So let's look also about the population. To close the picture here, to see how that's going to impact the future, let's look at the population of the Earth. So if you know, since the beginning of the human evolution until the year 1800, the total population of the Earth was about 1 billion people. In the span of 200 years, we went from less than 1 billion to about 7.5, and that trend continues to increase to about 10 billion in 2050. So if you look at that, you know, we have an interesting scenario here where we have actually less engagement in most of the jobs that human can do, because computational systems, you know, automation, all these technologies can do the jobs of thousands of millions of jobs of people. At the same time, we're having unparalleled growth in the amount of people actually being put into the system. So what does that tell us? That tells us that the current economic models that we have today are not going to be sustainable the next 30, 40, or 50 years. So we need to start thinking about what are going to be the new economic models that will be able to adapt and work with these things here. The same thing is social fabric of society is changing substantially. Look, for example, a long time ago, people, whenever they wanted to communicate with each other, they just, you know, talk in person or call each other with the phone. You know, nowadays, most of the teens, actually, about 50 to 60% of the communications occur through social media or electronic means. So it's still communicating human to human, but you're still doing it through media and electronics and technologies. And the next phase is actually where people will be communicating with artificial intelligence. So imagine artificial intelligence so powerful that actually it can be an amazing assistant, an amazing friend. The compatibility factor will be almost identical to yours. So we'll be actually having traits similar. You'll develop a trust system. The question is, there's advantages and disadvantages. If you develop such a trust with the system, and then that system is not secure and can be hacked, it can potentially convince you who to, you know, what products to vote, what philosophies to adopt, you know, who to vote for, and so on. So all these technologies come with advantages and disadvantages, and we need to make sure we tackle all of them before we become mainstream. So the key is, you know, we need to build really a bridge between academic institutions and industry. Because, for example, if you're producing engineers or producing scientists or medical doctors, and then by the time they finish in 5 years, that technology, a lot of the things that have learned are no longer applicable, then we have a problem. So constantly, the academic institutions and industry and government needs to be tied together to be able to actually to work and be able to produce a state-of-the-art, to be productive and to be effective in the workforce. And I think education itself will be more personalized. Look at medicine, for example. We're doing a lot of personalized medicine right now. Genetic composition of humans is very different. So why give everybody the same pill or the same medicine when all of us are different? So at the same rate, we're looking at education. How can we do education more personalized? Typically, a teacher sits in front of a classroom and teaches the same style, same methods. And some people actually are not following. Some people are bored because this is so basic for them. Some people learn by repetition. Some people learn by graphics. So people's intellectual capabilities vary substantially from one person to another. So why treat them all at the same time? I think individualized education is something that's going to be infused in the near future as well. So let's talk about the new technologies that are being implemented right now. So all these things are getting into the work field, but the thing is, what are the ecosystems that are going to be behind those kind of things? If you look at the internet, for example, the internet was a technology, and at the end it resulted in $7.5 trillion in economies. So what are the new ecosystems? What are the new technologies and new economies out of these actually technologies? That is what we're looking at right now to be able to predict and be able to have an advantage there. And technology is no longer applicable to a single industry. A lot of people ask me, for example, can you tell me what is the best technologies or best innovations you have invented this year and in your field? And by the way, that doesn't exist anymore. So a technology in one field applies to every single field. Look at the 3D printers, for example. Initially, it was thought it's going to be something just for manufacturing, for producing parts. But it turned out to be completely not the case. So look, for example, it's being right now produced to generate food. It's being used currently in a lot of restaurants. In the future, we'll be able to give a command to your personalized printer at home, be able to, for example, print a pizza or print foods. So they're doing a lot of advances. A lot of companies and startups are starting to have substantial advantages and progress in these kind of printers in the food industry. Also, look at the clothing industry. So you'll be able in the future to go, for example, to a place, have a scanning, laser scanning of dimensions, and by the time you drink a coffee or tea, you'll have everything selected according to what you wanted with these specifications. And then the next phase, we're putting a lot of electronics in these smart clothes. So clothes will be smart. We'll actually be able to measure a lot of the health characteristics. You'll be able to do communication. So the clothing industry is changing substantially, but the 3D printing technology will have substantial impact on that as well. In the medical field, we're having also, I think in the last month, some researchers were able to print a heart made completely from 3D printed capabilities. So that will be actually help substantially the human race, where you no longer need to be waiting for a donor. You can actually have an organ based on your DNA specifically, where you have 0 rejection chances, and being able to help you with that. So that also extends, it's going to help extending the human lives of that. In terms of houses, right now we can actually print the whole house in about 2 to 3 days at the fraction of the cost that actually costs you to build a house. So imagine how many people will have access to a new home, to new residence. And well, before it would have been very difficult to do that. And products also, obviously, anything you can print with this. But for us, obviously, for space, it's very important because when we go to a different planet, it's going to be very challenging to take all the spare parts with us. It's impossible. So what we need to do is actually find in situ resources in the planets that we're using. For example, use the sands in Mars or the Moon, and be able to use them as a feedstock for the 3D printing capability, and send the files, for example, from Earth, and then print whatever parts that you need with the material that you have on Mars to create habitats, to create spare parts, and so on. And I think that's going to have a substantial benefit to us wherever we go. I'm going to talk quickly about disruptive technology. I'm just going to hit in one example that I think is excellent. And I like to use the Netflix because not only they disrupted the industry, but they kept disrupting themselves. And that tells you actually, if you are successful, if you develop something, if you are innovative, and you are the leader, doesn't mean you're going to be the leader in a year from now. Things are moving so fast, you need to constantly be adapting and changing. So Netflix came at a time, for example, when there was a gap in the market. It was the big cassettes, and people used to pay a lot of fees for being late. And it was also very uncomfortable for people. It was creating some issues. So with the development of the DVDs, Netflix actually came in as a startup and started creating an excellent distribution scheme around different cities. So within 1 or 2 days, you were able to get the DVD developed and delivered to your house, and with a subscription model. So they created a subscription model that you don't have to pay late fees. You can keep it as long as you want, and when you finish, just put it in the mail, and that thing goes back to you. And they were very successful, having a lot of traction. They offered to themselves the services to Blockbuster. And strategically, Blockbuster did not see the connection, and unfortunately did not want to work with them. And then we know what happens. Blockbuster went out of business. So Netflix became actually the place to go to rental movies. And they were successful. They were #1, but they were not satisfied there. With the emergence of broadband technology and people now able to see movies instantaneously, so they developed a whole library. They invested substantial amount of money in developing a library online where people can actually immediately go and stream any movie they want instantaneously without having to wait for it. And again, they reached the market. They were #1. They beat all the competition. But then strategically, they said, we need to keep moving to the next step. So what they did is also they reinvented themselves. They went to 3.0, basically, which is they became a content producer. So not only they started creating their own movies, their own series, and some of them are very successful. Actually are winning Oscars, winning huge awards. So it's an amazing thing. And still, they're not satisfied with that. So recently, they started venturing into interactive movies, where we actually, you have the option to select how the movie goes, what direction the movie goes and ends, and so on. So that tells you about, if you want to be successful, innovation, and if you innovate something and you stop there, that's not going to be it. You constantly need to be moving forward, adapting and modifying and changing, because innovation is a fast-moving field, and you need to keep moving up with it. Look, for example, at the smartphone when it came out. How many industries has it disrupted? Who carries an MP3 player, for example? Who carries a radio or camera? All these things, all these industries got disrupted by a single technology. And the phone industry itself, in about 15 years, will be substantially disrupted as well. Nobody will be carrying a phone by itself. It's going to be something embedded in us. It's going to be different technology. So when you're trying to actually strategize, you should always look about what's going to happen in the future. Don't start investing in technologies that are available today, because you're always going to be behind the curve if you do that. So what you need to do is strategize about and look what's going to be actually happening in the near future. And the problem is when we do that, a lot of people anchor themselves with today's technologies. They don't extrapolate what's going to happen in terms of technology and use that one as a base camp, as a foundation to move forward. They base it on the current technologies, and sometimes that's why people fail predicting what's going to happen in the near future. So there is a lot of things you can do, actually. You can look, for example, at the amount of patents, where patents are going, what research papers are focusing on, what venture capitalists are investing in, what is the total market economic conditions look like. And if you use all that stuff, actually, things become less hazy. You'll be able to get better prediction. And if you are a good strategist, actually, you can actually start looking at the startups. The startups actually have the potential to disrupt a lot of big industries. It's probably sometimes one person, 2 people in their garage coming up with the technology. And that technology actually has the potential to disrupt a multi-billion-dollar company. So you need to be aware. You need to actually be a scout and look what's happening in the startup world. And to do that, who's better than having a relationship with venture capitalist firms? When all these startups typically, they require actually, funding. So the venture capitalists are typically very well connected with all these startups. So it's very good to establish that relationship. And if you are a strategist or an executive in a company, you need to actually look at all these kind of things and put a strategy for your company. So to predict and what's going to happen the next 5 years, the next 10 years, start investing, start becoming the best at it. Because if you do that, you're definitely going to be leading the competition, and nobody's going to be ahead of you. So a lot of people ask about creativity. Is creativity something people are born with, or something you gain? And I think it's both, actually. And obviously, people are more creative than others by nature, but also it's something you can learn from the environment you're exposed to, from the things that you read, from the classes that you take. It's something you can substantially become much more creative if you want to learn that. And let me give you a quick example about being creative. Sometimes coming up with innovative ideas doesn't require a lot of money. It just requires a simple, brilliant idea. So this is a company in the Netherlands, for example. They produce electronic bicycles, very expensive, with a lot of technology. And they were noticing that about 70 to 80% of the bikes were having damage in shipping, because people were the shipping companies were thinking they were bugs, so they were treating it in rough conditions. They were moving it fast, and they weren't being careful when these things were being shipped. So one of the guys from the company came up with a brilliant idea, said, what if you package these boxes assuming they are actually TVs? So on the outside, all they did is just reprinted the packaging, and they showed it's an LCD. It's not a bicycle. And because of doing that, I think they solved almost 80% to 90% of the damage they were having. So it's something very simple, very creative, who actually can go a long way in solving problems. Believe it or not, a lot of innovation comes from nature as well. For example, there is an artist, Dan Rosegaard from the Netherlands. He's looking at algae, creating new sidewalks where actually you don't have to have this big lights and consuming a lot of energy. You're creating a lot of sidewalks with algae. Whenever it gets agitated by you walking on it, it illuminates the space in front of you, and you don't have to use absolutely any energy. The second project they're working on is actually there's a bridge with a lot of buildings, and they were looking at illuminating all these buildings with conventional energy. So he came and he looked at one of the butterflies, and he noticed that the butterfly structure is very bioluminescent. Actually, if you very shiny. So they took the microstructure, they analyzed it, and they created a special kind of paint. And that paint, they analyzed it and put it into these buildings, and it was actually much more efficient than having actual lights. So it was very sustainable, no cost, and it was a very creative idea as well. There is tons and tons of examples we can talk about innovation from nature. Nature is very innovative through billions of years of evolution, and you can learn great lessons from that. So I'm going to talk quickly about acceptation. So acceptation essentially is something that was intended for one reason, and then it was co-opted to be used in a completely different manner. So I don't know if you know, but birds actually, the feathers were not intended for flying. So the feathers on the bird were intended for thermal regulation. And with time, with evolution, when the birds were trying to repel insects, it started moving their wings, they started levitating a little bit. So with time, with thousands and millions of years, they developed these capabilities to fly. But the original intention was actually just for thermal regulation purposes. So it's always good to be able to use and look at technologies and areas and ideas being used in one topic and try to find completely different topics in a different unrelated area. You'll be able to create substantial value. Just to give you this quick example, this is the car mechanic from Argentina. One day they were having dinner, and he was opening a bottle of wine, and the cork fell inside the bottle. And they were trying to get the cork outside of the bottle without actually breaking it. So they tried different things. Nobody was successful. And this guy eventually came up with a plastic bag, put it inside, inflated it, and got it out without actually breaking the bottle. So he went home and started thinking about what else I can use that for. It seems like an interesting idea. I'm sure there is other applications for it. So he called a friend of his. He was a gynecologist. And he said, what applications can be used for this? So because of this simple thing, they developed actually a delivery system for babies that actually is used right now in developing countries, and was able to save thousands of people's lives in countries where they don't have advanced technologies just by using this simple thing. So you can see from somebody having a dinner, drinking something, to develop a technology that was able to save thousands of people's lives. So you always have to be crossing, and thinking completely different out of the box, and you'll be doing amazing success. Open innovation is something also we've been using substantially. It's changing the equation. It's changing absolutely everything. So in open innovation, we notice actually that people that have less information, less knowledge in this field can produce the best results. And about 70% of the best solutions come from completely areas that nothing to do with the area you're trying to find a solution to. Look at this quick example I'm going to show you here from Harvard Business School, from Harvard University. So initially, they were trying to come up with a sequencing for an algorithm. And the initial one took them millions of dollars, with several years, and the accuracy wasn't very good. It's about 72%, and the duration was about 4.3 hours. So they decided we're going to bring actually 2 postdocs, give them about $120,000, and try to improve it and modify it. So they did that, and they were able to actually reduce the amount of time to about 47 minutes and increase the accuracy. And then with the emergence of open innovation platforms, they did the same thing and put it in the market on the internet. And the solution actually came at $6,000, 16 seconds to solve it, and about 80% accuracy. So you can tell now how open innovation, and by the way, the person who changed it, came up with the solution, has nothing to do with the medical industry or medical field. It's completely an outsider. So that tells you the power of open innovation and how much success you can have. I think that the challenge that a lot of people are having by using open innovation is if you advertise what your problems are, essentially you're telling your competition what the issues are, and might actually have some some challenges. So right now, they're doing it in a ways becoming more anonymous. And you can advertise what you're trying to do in a different way. So, for example, this one was a potato chip company was trying to get rid of the excess oil. And typically, they did it with shaking. And we're breaking a lot of potato chips, so creating a lot of damage that unused potato for the company. So they put it online, and they said, okay, we're going to actually have a challenge for how to remove a viscous fluid from a delicate wafer. And believe it or not, the solution came from a violinist. So a violinist actually found that when you hit certain wave, certain vibration, acoustic, you can actually remove the excess oil from the potato chips without causing any damage. So this is just quick examples to show you the value of open innovation and how much success and benefit you can bring to your company. Leverage on what's available out there. Don't concentrate on what you have only in your company, because there is millions of people, very smart people with amazing ideas that actually can bring you amazing solutions if you can leverage on that. So there is two types of innovation. There is revolutionary innovation and there is evolutionary innovation. For example, the iPhone, when it came, it was a revolution. We saw the earlier speakers showing the Nokia and how a conventional phone. So when the smartphone came, that was a complete revolution. And then evolutionary is, for example, what's happening in the smartphone from now on. We have, iPhone 4, 5, 6, 7. It's the same thing, just a little bit more modified. So the thing with revolutionary innovation, it's very expensive. And over 90% of the cases or the products end up in failure. So why do people keep investing in it? And let me give you an example of Apple. Apple, for example, is a computer company. That less than 10% of the revenue come from computers. Actually, about 60% come from iPhones. So imagine if it did not invest in revolutionary innovation, where would it be today? By doing that, they were able to substantially open a new market, a new area, a new technology that substantially changed their whole business. So that's why a lot of people until today invest heavily in this disruptive innovation, because it definitely has a big potential to improve it. And no matter what you do, you always have to take risk. If you don't take risk, there's nothing's going to happen, right? You're always going to be consistently, looking at getting out of your comfort zone, doing things differently, taking a challenge, And if you do that, definitely you'll be able to make some progress. A lot of people are talking about also when you start new companies and what to do. And I would say you should actually validate your early assumptions early. So there's no point, for example, in establishing a company, spending so much time, hundreds of thousands of millions, and then you realize the fundamental assumption that the whole company was based is flawed. So a nice example is actually Zappos. It's an online company that sells shoes. And what they did is they said, before we invest all this amount of money, and time and energy, let's see what is our fundamental assumption. The fundamental assumption in this case was, are people going to buy shoes online or not? So what they did is they went and they bought hundreds of shoes. They created a very simple web page. They bought a bunch of Google AdWords, and they went and they launched in the market. And they realized that actually people were buying shoes online, and actually it was a successful business model. And because of that, after they validated that, then they spent the millions creating distribution lines, warehouses, technologies, all that stuff. And at the end, they were very successful and ended up being acquired by Amazon. So it's very important to tell what is the fundamental assumption, validate it before you move on to the next step. And you have to be part of the new ecosystem. For example, a forest is not just different trees. It's a whole ecosystem. A forest, as a matter of fact, is connected with a wide web of fungus underneath it. They communicate with each other. In certain cases, they can actually, if there's an infestation, they can communicate with each other to be able to tackle the infestation. They can transfer nutrition. If there is an invading species, they can actually unite and take it out of the equation. So the same thing is with big companies. I mean, nowadays, everything is an ecosystem. Nobody's working on silos. You have to be part of the big thing. And not only you have to work with other industries in your system, but you have to work with academia, you have to work with government. And if you create this vast network and a vast array of participants, I think the benefits will be substantial. You'll be able to create things you will never be thought were possible without it. When astronauts go to space, actually they look at something called the overview effect. So they look at the Earth in a different perspective. They don't see countries, they don't see borders, they don't see any of that kind of things. So if you're going to be a good strategist, you have also to pull yourself out completely out of your business. Go and look at the big picture, look at the whole thing. And when you do that, you're going to start seeing things in a completely different ways. and be able to come up with substantially better strategy to be able to change your business and be able to give you substantial advantage on that. So nowadays, I see a lot of companies, a lot of industries are coming up with amazing products, doing great successes. But imagine if all of us put our collective intellect together to solve some of the world's most challenging problems. I think the possibilities will be endless. Thank you very much.